Welcome, students. In this video, we are going to solve some problems on limits on sections 1.1 and 1.2. This worksheet here is uploaded to Moodle. So let's start. So here we have a function. Graph is displayed here. Let's find limit as x is approaching to 1. So this is equal to 2. Next, limit as x is approaching to 3 from the left side. So we are approaching to this point here from the left side. So this value here is equal to 1. So limit is equal to 1. Limit when x is approaching to 3 from right side. So this value here is 4. Next question is a two-sided limit at 0.3. It doesn't exist since these two one-sided limits are not equal to each other. So the limit doesn't exist. And the value function f at 0.3 is equal to 3. Okay, on to the next problem. One second, let me fix that. So we have the following function, limit as x is approaching to -3. So we can see that the left side and right sided limits are equal to plus infinity. So this is plus infinity. When x is approaching to 2 from the left side, so we can see that this limit here is equal to minus infinity. So our function is decreasing without bounds here. When x is approaching to 2 from the right side, the function is increasing without bounds. When x is approaching to -1, so -1 is here, both one-sided limits are equal to minus infinity. Next, equations of vertical asymptotes. We have vertical asymptotes at -3. So x is equal to -3. Next one is x is equal to 0. Next one is x is equal to 2. All right. Limit as x approaches to 3 from the left side. If we substitute some value that is smaller than 3 here, we'll get small negative number. To the odd power is also negative, so 3 over some small negative number is minus infinity. Next one, we can express that as x multiplied by the x plus 4. So limit x is approaching to 3 from the left side, x plus 4. In the denominator, the sum of roots is equal to 2. The product of them is -3. So this is x, or the roots are 3 and -1. So x -3, x plus 1. So if we substitute some value that is smaller than 3, we'll get here some small negative number. This is positive, this is positive, this is positive, and this is minus infinity. All right, next one is x multiplied by cotangent of x. So this can be expressed as x is approaching to pi from the left side, x multiplied by cosine of x over sine of x. If we'll take a look at the unit circle, then if we approach to pi from the left side, so if we take some value that is slightly less than pi, then sine is going to be some small positive number, and cosine is equal to 1. So this is pi multiplied by pi over some small negative number, which is minus infinity. You can also confirm that by looking at the graph of cotangent of x. All right, so let's sketch the graph of the function and use it to determine the values of a for which limit exists. Yeah, let's plot that. When x is less or equal than 0, we have decreasing function like that. When x is equal to 0, this is 1. Okay, next. When x is in the interval from 0 to 1, this is y is equal to x shifted down by 1. So it will look like that. When x is greater or equal than 1, we have ln of x. So ln of x at 1 is equal to 0. So we'll get a function like that. Okay, now let's determine the values of a for which a limit exists. So first of all, limit at point x is equal to 0 doesn't exist, since one-sided limits are different. Limit at this point here exists. One-sided limits are equal to each other. So limit as x is approaching to 1 from the left side, then we substitute 1 here, we'll get 0. And limit when x is approaching from the right side, we substitute some positive 1 here. Value of x that is slightly larger than 1. Then we get 0. So one-sided limits are equal to each other and equal to 0. So two-sided limit is also equal to 0. So on interval from minus infinity to 0, since at point 0 our limit doesn't exist, we are going to exclude that point. Union from 0 to plus infinity. Okay. Okay. Limit as x approaches to minus 5. Let's expand our denominator as x minus 5 multiplied by x plus 5. Here we have an immediate hint that this term should cancel out with a term from numerator. So one of the roots in numerator should be minus 5. The sum of the roots is minus 9 over 2. The product is minus 5 over 2. So first candidates are minus 5 and 1 over 2. Luckily, their sum is exactly minus 9 over 2. So this is x plus 5, x minus 1 over 2. Those two will cancel out. Limit as x is approaching to minus 5. We can substitute minus 5 here to find the limit. Next problem. So x approaching to 1. First root is 1. Other root is minus 2. minus 2 over 3. So x plus 2 over 3 in the denominator. Again, one of the roots is 1, and the other root is minus 3 over 2. So x plus 3 over 2. So cancel this through, and then we can substitute 1 to find the limit. All right. Next problem. Play around a little bit. Let's start with denominator. Let's turn that into 3. So we'll have t cubed minus 1 minus 3t plus 3. Okay. So this is equal to limit. So we can expand this as t minus 1 squared plus t plus 1. All right. Factoring out minus 3, we'll have t minus 1. So factoring out t minus 1, we'll get t cubed plus t minus 2 denominator. So this is our denominator. In denominator. Okay, so we have a hint that one of the roots should be t minus 1. Okay, if we turn that into 4. Okay, yeah, let's turn that into 4. So we'll have t cubed plus t squared minus 5t plus 4 minus 1. So grouping this together and t cubed minus 1 together, we'll get t minus 1, t squared plus t plus 1 plus one of the roots is 1. So t minus 1. Second root is 4 over 1. So this is t minus 4 divided by this term here, t minus 1, t squared plus t minus 2. So we'll have, factoring out t minus 1. So t squared plus 2t minus 3 over t minus 1, t squared plus t minus 2. Limit as the t approaches to 1. So those two will cancel out. We can further expand this too. So we'll have limit. One of the roots is 1. The second root is minus 2. So here, one of the roots is again 1. Second root is minus 3 over 1, so t plus 3. Okay, so the answer is then 4 over 3. Okay, guys, when facing these problems, if you notice some patterns, try playing around. If not, try starting by doing something with denominator to factor one term out as we did here. And then if you don't want to mess around with numerator, what you can do is you can apply the long division. So here we could apply long division and divide the numerator by t minus 1, right? And then you would get to this point here, and it's easier from that point. Okay, next problem. Find the vertical asymptotes. Let's expand our numerator. The sum of roots is 2, product is -8, so the roots are +4 and -2. The terms that appear here in denominator, they're going to be our vertical asymptotes. So we have vertical asymptotes at 4 and -2. Okay, next problem. Let's firstly find our one-sided limits. Limit as x approaches to -4 from the left side. So in the denominator, we have 2x plus 4. And in numerator, we have some small negative value. So this is negative. So we have a value that is smaller than -4. So that's going to result in negative value. So this is minus x plus 4. Cancel out. This is -1/2. Right-sided limit is when x is approaching to -4 from the right side. Here, the absolute value will open as positive. So x plus 4. So this is 1/2. One-sided limits are not equal to each other, so this limit doesn't exist. So guys, when you are approaching to -4 from the left side, you'll get some value that is less than -4. So something like -4.0, let's say 1. And when you're approaching to from the right side, you'll get some value that is greater than -4. So this is something like -3.9. If you substitute here, you can see that when we approach from the left side, we should open the absolute value sign with minus sign. And when we're approaching from the right side, that will open up with a positive sign. Okay. Next problem. When x approaches to 0 from the right side, that will open with a positive sign. So we'll have 1/x minus 1/x. So this is 0. Okay, next problem. So here we can multiply and divide both numerator and denominator by numerator. So we'll have limit as x is approaching to -4. Have x squared plus 9 minus 5. So x squared plus 4. And the denominator will have x plus 4. Of x squared 9 plus 5. Oh my bad, I made a mistake here. So we'll have x squared plus 9 minus 25, right? So this is x squared minus 16. So x squared minus 16 can be expressed as x minus 4, x plus 4. So x plus 4 will cancel out, x minus 4 divided by root of x squared plus 9. So this is 16, 25, 10, minus 4, so minus 8 over 10. Right, that will conclude our practice sheet on limits, at least limits from sections 1.1 and 1.2.